Anybody have any questions about the homework at all? I gave you a bunch of problems. I hope you all did them, because this is the toughest subject, this is the toughest topic in this course. No problem? You did? No questions at all? Yeah?
Could you do the third problem?
Yeah, give me describe it.
I don't have it with me.
Anyway. Third problem. Is this convolution of what? Two continuous functions?
Yes, I believe.
Could you tell me what they are? Anyone? I didn't print it out. Say again? You have to speak up. Say again?
Okay, I know the second one is 2t ut.
Okay, I'm going to just call it x of t is equal to 2 times go.
2t ut minus 4, and then parentheses t minus 1.
2 what? 4 times 2 minus 1?
Minus t minus 1.
Oh, 4 times t minus 1.
T minus 1, and then
Wait, 4 times t minus 1? Okay, go ahead.
and then that times u of t minus 1.
Okay. That's x of t. What's h of t?
And then there's also plus 2 times t minus 2 times u.
2 times t minus 2?
T minus 2 ut minus 2.
Okay. These are ramp functions, by the way. Those are, yeah, go ahead. What else?
I got my other one.
Anybody else got the other function? Just tell me.
Two brackets with.
This is h of t, right?
This is technically x of t. The other one was h of t.
I couldn't hear you. What?
The other one's h of t.
It doesn't matter which one. It doesn't want. Go ahead.
But it's 2 and then brackets it has u of t minus u of t minus 1.
All right.
Yeah.
Is that it? All right. For these functions, probably a good idea for a problem like this is to draw them. Now, I provide you the solutions, and I'm going to tell you, if you get behind here, you'll probably fail the first quiz miserably. This stuff just accumulates on you. It's very hard to play catch up on. So what I'm going to suggest is with a problem like this, draw the two functions. Understand that? Make sure you can draw them out and see what they look like. I'm going to show you h of t here. That's the easy one. Versus t right here. Can everybody see this okay? Class? In the far back especially, you guys. Now, this one's pretty simple. 2 is the weight in front of it. U of t, you know, turns on at t equals 0, correct? It's 0 before that, and it becomes 1 after that. Right, class? Now, it's minus u of t minus 1. Well, what happens here, when this one turns on, it subtracts from this one with a net product of 0. Do you all see that? So what this one looks like, that's at 1, that starts u of t, it turns on at 0. It's simply going to be 2, and it does this. That's this function entirely. Can everybody see this? This should be an automatic. You shouldn't even have to pause to see that. Does everybody see that, class?
Yes.
With me? Now, the next function may take a little doing. I'll try it right here. Versus t. For this one, these are all ramp functions. The t u of t is a ramp that starts at 0. The t minus 1 times u of t minus 1 is a ramp function that starts at 1. The t minus 2, t times u of t minus 2 is a ramp that starts at 2. Do you all see that, class? Those are simply ramp functions. He chose not to put r of t, and why, I don't know, but it's usually convenient to do that. So when I point, I'll call this my x of t. Now take a look at this. This one starts at 0, right? You all agree with me there? It's got a weight of 2, a slope of 2. So I can say this is going to go, that one turns on at 1, so it goes like this. This would have a value of 2 between 0 and 1, and be 0 less than that. Do we all agree with that, class? You all see this? Now remember, this function is going to continue on forever, right? The 2t stays there for any positive time. Do you all agree with me? All right, but now this one turns on, and this is subtracting. 4 times t minus 1, u of t minus 1. What does that actually look like? Well, that function itself looks like this. It's got a slope of minus 4. It's looking like that, right? You all see that? So now what happens? At this point, you add this plus this, and what actually happens here? I'm going to do this for you. I'm going to go ahead and add this and this when they're both on for t greater than 1. So watch this. For t greater than 1, but sorry about that. T greater than 1, but less than 2. I know they're both on, so I have 2t, right? Now my function is 2t, and then it's going to be minus 4 times quantity t minus 1. You all see that they're both on. So I eliminated the u of t and u of t minus 1. Understand, class? Now what is that going to be when you add them together? Well, I have 2t minus 4t, or minus 2t, right, plus 1, right? Do you all agree with that, class? 2t plus 1. Now listen to me. So when I come here, what's the value when t is equal to, for this one, when t is equal to 1? Now I have what? 1 minus 2, right? Or minus 1. Do you all agree with that, class? Yes, sir.
Should it be minus 2t plus 4?
What is, I'm sorry, can you?
Would it be minus 2t plus 4?
Oh, I'm sorry, you're right about that. I am sorry, you're absolutely right, plus 4. I apologize for that. You're right. Thank you for catching that. You're absolutely right. So if I look at this when t is 1, it should be continuous. That's my point I was going to make, and we were caught this one. This is going to be what? Minus 2 when t is 1, plus 4, right? Or 2. Now the thing about this should be continuous, and you notice it is continuous, right? Because it's now for t slightly greater than 1, it's 2. Do you all agree with that, class? How many see this, please? Let me know. Y'all see it? It's very, very obvious if you think about it. But now the slope is what? Minus 2t, so it's going to continue going down at minus 2t here. That's a minus 2, this is a plus 2 slope. And then at 2, what happens? Well, at 2, this one turns on, right? Correct? And what is that one going to have a slope of? Of 2. Do you agree with that, class? Now, let me just tell you, for t greater than 2, you can say 2 times t minus 1, t minus 2, minus 4 times t minus 1, plus 2t. Just write it out, and then see what the result is. And that will be the actual thing you're going to graph. Are you with me? But I know this is a ramp function right here with a slope of positive 2 that starts at 2. You'll notice at 2 here, it's at 0, isn't it, class? So then instead of continuing down, now you're going to add that 2t, and it'll just be this. So it should be a triangle. That's what it should look like. Understand, everyone? I drew it out on purpose for you. Now we're going to do the convolution. So when we're convolving these two functions, I've told you the way you do it is, the one in convolution, again, I'll put it up here, is defined as when we have the convolution of two functions, x of t convolved with h of t, that's really the integral from minus infinity to infinity of usually the first, and you can put tau here, times h of t minus tau d tau. But it doesn't matter if this is h and this is x. The order does not matter. Understand, class? So what I always tell people is when you're doing convolution, graphical convolution, showing it this way is a big help. You find the function that has the most variation. That's this one. And you don't flip and shift it. When I say flip and shift, that's what this operation is. All right? It's the second function. So that one we leave alone and we plot versus tau. And I'll do it here. So now I'm going to take my first, that function, and I'll call it x of tau. Does the book use lambda or tau?
Lambda.
It really doesn't matter. I'll put lambda then. They're a dummy variable. It means the variable itself is integrated out. It can be lambda, it can be tau. So now if this is versus lambda, right, it looks like this. And this has a value of 2. The equation for this line is 2 lambda right here. And the equation for this line right here, if you think of the zero intercept at 2, is going to be I believe. So this is the equation of that line, that's the equation of this line from here to here. Are you with me, class? See, when you're at lambda equals 2, the function is 0. So minus 2 times 2 is minus 4, plus 4 would be 0. I just found the intercept and put it in here. Follow me, everybody? Work with me now. Now we take this one and we flip it and shift it, just like I did last time. I come here and now I put, first I'm going to go ahead, put my h of minus lambda. That's when we flip it, right, class? I do it first, just to see what it looks like at 0. And this one looks like this. That's h of minus lambda. Does everybody agree with that? Please show me your hands if you understand that. Make sure you do. It's very important that you see everything I'm doing. Now, I can see when I add something to this actual argument, just right now it's 0 minus lambda, right? If I put anything positive in there, like 1, it'll shift this whole thing one space over this way. Do you follow me in this class? How many see that? Make sure you do this stuff, because people get confused. Some people think it's going the other way. Mathematically, go through, work it out, force yourself to do it. It's the way you'll learn and retain this. So now I'm going to go ahead and say, I'll take this one right here. I want to use this one, and instead of putting minus lambda now I'm going to put t minus lambda, but I'm going to say this is for t greater than 0 but less than 1. And now it looks like this. Oops, yeah. And this is going to be t minus 1. Does everybody see what I've done here with the height of 2? The only thing I've done is what? I've added this t and I've conditioned it to between 0 and 1. Can you all see it in the back? How many see this right here? Now, the next thing you do is, and the reason I said between 0 and 1, I want to limit that because it's a completely different problem once it's between 1 and 2. Now this triangle would be, this rectangle would be moving here, right? And part of it would end up here, the back part would hit here, and the front part would hit here. It's a much different problem. Understand, class? All right, so let's take a look at this. Where's the area of overlap, or the region of overlap? This is a good problem. It's right between here and here, correct? Now I need to get the product of this times that in that area of overlap, correct? So I'll put the product next, and when you take a look at that down here, that would be 2 lambda times 2 or 4 lambda. So now it's 4 lambda, and t, I'll call this 1 here, that's 0. Now this right here is simply x of lambda times h of t minus lambda. And according to convolution, the next thing I have to do to actually get the convolution of these two is integrate this function between here and here. Right, class? How many see that? So when I integrate that function, what do I get? I'm just going to put it down here. I'll call it y of t. Y of t would be equal to, well, it's the integral from where to where, class? Take a look.
0 to 1.
Ah, t, right? It's anywhere between 0 and 1. Understand, class? T is what I added to there to shift it over just t, correct? Everybody see that? So now it's going to be the integral from 0 to t of 4 lambda d lambda, or now it's 4 lambda squared over 2 from 0 to t, or it's simply 2t squared. And this is true for t greater than or equal to 0, less than or equal to 1. And that's my y of t, or the convolution of these two. Let me go ahead and say this is y of t to make sure everybody sees it. Output of a system. How many see that much? All right? Take a second, really grasp this. And this gets complicated quick. These are more simple problems, but it gets really complicated in a little bit. But you've got, once you see how you do this, all the problems fall apart. There's more complexity, but you see what to do. All right, now the next thing I'm going to do is say, I hope you don't mind me using the same drawing, just this middle part erase a little, because I'm trying to I'm trying to save some board space. So now the next thing I do is say, now what happens, I say t is between 1 and 2. Now when it's between 1 and 2, now my h of t looks like this. If this is 1 and this is 2, it looks like this. The front is still at t. This is t minus 1 because the width of this thing is 1, but it has a height of 2. How many see this right here? Height is 2. Now it's shifted into a new era, right? Now it's between t and t minus 1 still, but there's something different. When we multiply this times this, we get two different products. We get this product here, 2 times that is just 4 lambda between t minus 1 and 1, right? And between 1 and t, we get what? We get 4 minus 2 lambda times 2. Agree, class? So there's two different areas, two different regions we have to consider. Do you understand? These are the problems that oftentimes people fall apart on. They just say, oh, it's getting too difficult. And if you have that attitude, you're probably not going to be an engineer. You have to maintain that this is a challenge, and you're going to meet that challenge, and you're going to think it through. You cannot say, oh, it's too tough, because it gets tougher as we go, and a lot tougher in some of your higher level courses. So now when we take a look at the product of this, I'm going to put 1 here, and I can see that the first product from t minus 1 to 1 is going to be 2 times 2 lambda, and I'll just draw it like this. This is really going to be what? 4 lambda between t minus 1 and 1, and then here it's 4 times 2 minus lambda times 2, or it's going to be 8 minus 4 lambda, right? And that goes from 1 to t. Please see, this is the product. I should write it down. This is the product of x of lambda times h of t minus lambda. Can you all see that there? Can you read it in the back? Far back? All right. Did anybody use that Java applet I sent you to do the convolution? Give me a show of hands how many people tried it. The thing I gave you is a godsend. You can actually draw the functions you want, let convolution take place, and it'll show you the output. If you haven't used it, I suggest you use it and really, really spend some time with it, because just watching that stuff, all of a sudden lights go off in your head. You see things that were darkened to you didn't see before. Understand? So please make use of that. Now, I have to get the area under this curve, correct, class? Y'all agree? So let's do it. And if you don't mind, how about if I do it over here? I don't know who asked this one, but this is a really good problem. And please remember what I told you in the beginning. Draw the functions out. Yes, sir?
If it's from 1 to 2, do you even worry about the left of 1?
We're going to get to that. Now let's just do it piecewise. All right. Between, but this is for t greater than 1, less than 2. All right. Once it's greater than 2, it's a little different. Now it's only the tail end. It's only the last part. All right. This is the hard part right here, actually. So now I can say my y of t here would be equal to the integral. Take the first one of 4 lambda, right, d lambda, and that would be from t minus 1 to 1. It's going to be that. Then it's plus the integral of the quantity 8 minus 4 lambda d lambda from 1 to t. Does everybody agree with that? All right, make sure you write it down like this when you're doing this on a quiz or a test and in your homework. Be methodical. Don't get lazy and skip steps, because you usually make mistakes. I know you guys see what that is, all right? But just do it. So here, this is still going to be what? 4 times lambda squared over 2, or 2 lambda squared. So it's 2 lambda squared evaluated between t minus 1 and 1. I'm going to write that down for a reason. I know we can plug in the numbers right now, but I want to make sure you get used to doing this so you don't make careless mistakes. Oftentimes when you try to do too many steps in your head, you'll make mistakes. Next is going to be plus. I'll do the first one. When I take 8 d lambda, I get 8 lambda, right? So it's plus 8 lambda evaluated between 1 and t. And then it's going to be minus, and here we get the minus 4 lambda d lambda is minus 2 lambda squared, right? And it's evaluated from 1 to t. Do you all see this? I'm just writing down piece by piece, so get used to that for a while. Yep.
So can you still combine the second two, or
What?
just the 8 lambda and then minus 2 lambda squared?
If you want. I mean, but see, this has got a squaring operator and that doesn't. I'm just doing it this way if you don't mind.
Okay.
Now, go ahead and do it. What do you get for the first one? Well, this is going to be what? 2 times 1 squared is 1 minus the quantity t minus 1 squared. Make sure you put that down there. This is where people usually make a silly mistake. They'll do something stupid in the squaring operation. Then it's going to be plus 8 times t minus 1 minus 2 times t squared minus 1 squared. Agreed, class? Everybody? I'm just doing the operations. What happens next? How about the first one? What do we get? We get 2, right? Right? Minus 2 quantity, then you get what? T squared, right? T squared plus 1 minus 2t here. Do you agree with that, class, everybody? Keep going. What about this one? Plus 8t minus 8, right? Minus 2t squared plus minus 2t squared plus 2. Agreed? I don't know who asked this, but this one, see, I'm spending more time on this than normally I would do, and you'll get good at it, but do it the way I'm showing you so you don't make a mistake. All right, go ahead and start combining things. Let's take the constants. We've got what? I've got a 2, that's 4, and I've got a minus 8, right? And, well, I got another thing here. I gotta break out all of them. Let me do one more step. So this is 2 minus 2t squared minus 2 minus 4t plus, what?
Would that be plus 14?
Or plus 4t, you're right, plus 4t. Minus t squared minus 2t plus 4t, right? These things are starting to look like plus. Plus 8t minus 8 minus 2t squared plus 2. Agreed? All right. I'm going to put a plus there. Agreed, class? All right. That's a minus 2, that's a 2. I'm getting rid of it. Agreed? Now, next I'm going to get with the power of just t's. Or, well, wait a second. Then I got the minus 8, so hold on. Tell you what, do me a favor. You guys, my back is not good. Let me just stand back here. I've got 2, and 2 go away. Then I have minus 8 and 2 at the back, right? So I've got minus 6, correct? All right, minus 6. Help me out, guys. Next, I want to go with the factor of just t, so I have minus 2. I'm sorry, I've got plus 4t plus 8t, right? That's 12t, and that's it. Is that right, class?
Yes.
What else? Then with the t squared operator, I've got minus
4t.
minus 4t squared, that's right. Minus 4t squared, and that would be y of t for t greater than 1, less than 2. And this would be less than or equal to 2. Agreed, class? Sorry it took so long. Finally, now we're going to let this thing move through, and now it's going to be greater than t, greater than 2, but less than 3. Because if it's 3, then this box is to a point where there's no overlap. Follow me, class? How many see that? Yes, sir? Did you have a question?
So since both your functions that you're putting into the convolution are symmetric, would it be faster to assume that your next function that you're about to derive will be?
You're ahead of the game. He's saying that you can exploit symmetry. You're absolutely right about that. The reason I'm not going to do that is because at this point in time, I think it's important that you work through every step. You're absolutely right what you said. He said it's going to be symmetric necessarily because the two functions are symmetric. The output will be symmetric, and once you're at where the center of it is, you can automatically fill in the second part. Let me say one other thing, and some of you people probably did the reading in the book about this. If you look at this function, it has a width of 2. This function has a width of 1. The final form of y of t will be non-zero only for the region that is going to be the summation of this width plus this width, or 3. Now, hear me on that. If you got the width of the first function is say A, the width of the second function is B, the width of your answer when they're convolved will be A plus B. That's the nature of convolution, understand? Now, if they're infinite, then it doesn't matter. But if they're finite, this happens. Understand, class? Now, he hit the nail on the head. He said, all right, well, I know the thing's going to have a width of 3. Well, I've already gone from 0 to 1, right? And now from 0 to 2, over there, that's the answer. That's from 0 to, or I'm sorry, from 1 to 2. And I know the halfway point would be 1.5. Do you agree? If the total width is 3? So what he's saying is if you just sketch this and this, that you could fill it automatically, the second part, and he's right. Are you with me? But I'm going to do it anyway. It's just because that way you'll learn to just do this. You're going to learn to exploit symmetry later. So let me go ahead and take care of the last part right here. So finally, now we're going to go from t greater than 2 but less than or equal to 3. So here, now it looks like this. Here's 1, 2, 3. Now my box is basically here. It's still, the front is at t, and the back is at t minus 1, and the height of this is 2. Are you with me? Just draw it up there. And I mean this too. This takes hours and hours of time, usually for most engineering students, doing problems. Don't assume, oh, I got this. Make sure you do a lot of problems to it's almost second nature, what you need to do in the answer. And people get real sloppy sometimes. As soon as they want to move through it fast because they got something to do, and that's when errors come in. Be very meticulous. Now, where's the area of overlap for this one, please? When I'm looking, where do these two functions in the lambda domain have a non-zero values? Class? T minus 1 and 2, correct? That's between here and here. So really, I have to multiply 2 times this and integrate it from t minus 1 to 2. Do you see that, class? All right, so finally, I'll do it right here. Finally, I get 2 times that, which is going to be the integral. This would be 8 minus 4 lambda, d lambda, and it's between t minus 1 and 2. And this will be my y of t. Now, that will look like, and this is for t greater than 2, less than or equal to 3. Take a look at this, class. When I integrate 8 d lambda, I get 8 lambda, right? I get 8 lambda, and I evaluate it between 2 and t minus 1. And then I get minus 2 lambda squared evaluated between t minus 1 and 2. So this is going to be what? We'll just get rid of that there. It's going to be what? First one is 8, right? Times the quantity 2 minus quantity t minus 1. Catch me if I make a mistake. Minus 2, right? Times lambda squared. Well, 2 squared is 4. I'm just going to go squared. And then I have minus t minus 1 quantity squared. Do you all agree with that, class? Everybody? What does it come out to? Well, I'll let you write it down. Take a look at this. I got 8 times 2, that's 16, right? Then I have minus this stuff. That's minus t squared minus 1, right? Here, class? Well, you know, I'll tell you what I'm going to do. I'm just going to do this. I'm going to leave the 8 there, and then I'll have 2, and then it's going to be minus t squared minus 1, and then plus 2t. That's this part. And then I'm going to have minus 2 times the quantity 4 minus t squared minus 1 plus 2t. Just filling out. You all agree with this, by the way? Whoever asked this? I'm spending too much time on this, but that's okay. Now, I look here, and I have 2 minus 1 or 1, agree? I'm gonna just put 1 there. Then I have 4 minus 1 here, or 3. And then, I think we can get them all right here. If we look, that's a 3, by the way, it's a lousy 3. Now I've got 8 minus 6, correct, class? Or 2. What about for t? What's the value for the coefficient of t? Well, that's 2 times 8 is 16t at the top one, right? Bottom one is going to be minus 4t, correct, class? Or 12t, is that right, class? Okay, so it's going to be plus 12t, and then finally what? I got minus 8t squared, minus 2t squared, or minus 10t squared, don't I, class? And this is for t greater than 2, less than or equal to 3. And that would be the y of t. And then we've got it for all, let me finish this train of thought. Did I make a mistake? If I did, let me.
Wouldn't it be plus 2t squared?
Where did I do so?
Minus
Well, you're right. So this is actually 6, right? Thank you. Thank you. I am trying to get through this fast, but it ain't working. Do y'all agree with this? So that's y of t. Thank you very much. Agree, class? Yes, sir.
So why does it integrate down to 8 lambda instead of 4 lambda?
I don't know what you mean. Show point. Tell me where to
See,
go.
when it says y of t is equal to 8 lambda from 2 to t minus 1, why is
Oh,
it
that's
8?
just the first part. 8, the lambda is 8 lambda. And the second part is going to be minus
Oh.
2. It's really minus 4
I'm dumb.
lambda squared over 2, or minus 2 lambda.
I'm dumb. I
No,
divided
you're
it
not
incorrectly.
dumb. Believe me. You're not dumb. Understand? Go.
How'd you get the t squared right there when it's 2 minus t minus 1?
Okay. Help me out. Where do you want it?
Up.
Up?
No,
Up? Here?
no, down there.
Down? Here?
The t squared right there? on
This
that
one?
line?
This one?
Yes, where'd that come from?
This is t minus 1 squared. First term would be t squared.
Oh, okay, so
Minus
it's
one.
from the second.
Yeah. I'm trying to do this efficiently. Yes? Yes?
I think he accidentally, for that one, mixed up the,
It's
I
for the
think he
first
mixed
part.
up the two.
What?
It's for the first part, I believe he's pointing out. See the 2 times, the 2 minus, the 2 minus t, right? Then you got the 2 minus the.
What's that?
I guess you, distributed the negative sign.
Which one? Is this what you're talking about?
Sort the question that he just asked, where he got the t squared, I think he
Yeah,
pulled it from the wrong.
What's that? When you take t minus 1 and square that, you get t squared, right? Then you get minus 1 squared of 1. So you get t squared, and there's a minus sign in front of it, t squared, 1, and then you get these two times each other twice, minus 2t.
Yeah, but you have that written down underneath it.
Huh?
You have it written down underneath it. The second.
3 minus t squared.
Yeah, because 4 and then 4 minus 1 is 3, right? Just take a look at this. This is going to get a t squared and a 1, right? With a minus side. 4 minus 1 is 3, isn't it?
Yeah, so for the top one, you got it for that left equation, and there's only 1 t in there.
Right.
And it's not squared.
Hold on. Are you talking about this right here?
No, the other, the
You're
left.
talking about this.
Yes.
That's this.
And there's no, where'd you get the t squared?
That's there. That's wrong. That's wrong.
There we go.
Can we do me a favor on this one? I was trying. Just go through the math on this one the way I've showed you, all right? The answers are there, all right? The right answers. But that's how you do it, the mechanics. Whoever asked that question, it's a great problem. Sorry, I'm trying to hustle through this, but we got a few more to do today. Any other questions about the homework? I'll try to go through them efficiently and carefully. Anyone? All right.
It's related to this problem, but our final answer is, do you want them to be piecewise or all combined?
They have to be piecewise. You have to say between t equals 0 and 1, then 1 and 2. There's no way to combine them unless you want to put u and t functions out. You can write a cajillion u and t's, but don't do that. Just put t greater than 1, less than 2, stuff like that. Always regimes.
The book has a bunch of you.
Well, the book can do that, but you don't. What I always ask for is I'll give you like 3 or 4 slots. Fill it in. Y of t is this between 0 and 1. It's this between 1 and 2. This between 2 and 3. And you put down where the limits are. I don't put those down. And the form. Apologize for the mistakes, silly mistakes. My penmanship is horrible, and my back is hurting. What's the other problem? Anybody? Because those are good problems I gave you. Anybody? Because I got one for you if you don't. I hope you all did them. Yes, sir.
Problem 2.14.
You're going to have to tell me.
It's functions x of t and h of t are given x of t is piecewise, and it's 0 for t.
Is this a plot show?
No plot shown.
Okay, what is it?
0 for t is less than 0. Sine pi of t for 0 is less than or equal to t, and then less than or equal to 1.
Mm-hmm.
And then 0 for t is greater than or equal to
Else, fine.
And then
That's
h
fine.
of t is just u of t.
What?
H of t is just u of t.
This is an easy one. All right, for this problem, of those two functions, which one has the most going on? The sine of t, right? The first function, x of t. So we put that as sine or x of lambda. We just leave that alone. We don't flip and shift that. Got it, everyone? So we just leave it alone. So now we put down the sine here of pi lambda versus lambda. And if you think about a sine, that's from 0 to 1. Is that right?
Yes.
All right. Well, let me space that out a little further. If it's from 0 to 1, let's make 1 over here. That's just half of a sine wave, isn't it?
Right.
That's all it is. Peak is 1. Agreed, class? Now, this is u of t, the h of t, right? So we put h of minus lambda. So h of minus lambda, and that looks like this. That's u of minus lambda. Do you agree with that, everyone? I don't want to run through this stuff, but please, this is not this hard. If you've done these problems, this is obvious, and I hope you all did. God help you if you didn't, because by Friday, you're going to get a whole bunch more homework tonight, and by Friday, I'll just be overwhelmed. You all with me on this? Now, that is when the value of the offset here is 0, right? I haven't stuck in a t value yet, but it would be as if t is 0. Do you agree with me? Now I'm going to put t in there. And I'm going to say now it would be h of t minus lambda, but now I'm going to say this is true for t greater than or equal to 0. And I don't have to, and I'm going to also say between and less than or equal to 1, because here's what's happening. This is a curtain, has an infinite length, if you think about it. Agree? Now this point will be t. And I'm going to draw this curtain through here until I hit 1. Only in that regime. It's between 0 and 1. Anywhere between that range. Now after 1, it's different because that means the total amount of overlapped area will be a constant of 2 after that point. You got me on this, class? So let's go between 0 and 1. And you can see that the overlapped area is this times this. It's 1 times that. Agree? And here we have to integrate. So now I can say my y of t will be 0 for t less than 0. Y of t will be equal to the integral from 0 to t of the sine of pi lambda d lambda. And that's going to be true for t greater than 0, less than 1. Agreed? Now I'll do that integral in a second. We can do it right now. What's that integral going to be, by the way? Just take a look. The integral of sine. Think about it. It's going to be what? Minus cosine? Yeah, isn't it? Derivative of sine is cosine, right? That's minus cosine, isn't it, class? But the pi, what do we do with the pi? 1 over pi, right? Minus, right, class? And then you put a cosine of pi lambda, and you evaluate it between 0 and t, and that would become y of t here would be minus 1 over pi, and here we get cosine of pi t minus cosine of 0. What's the cosine of 0? 1. Thank God. So I can flip these things around. I have 1 over pi times 1 minus cosine of pi t. And that's the value of y of t between, where t is between 0 and 1. Understand, everyone? Now what happens when t is greater than 1? Think about the curtain being drawn. Now t is greater than 1. Well, that's 0 times this out here, isn't it, class? So the product of that is 0. It doesn't matter how far out you go. What do you notice? That value is just going to be the area under this curve, is it not, class? How many see this? What's that area? Well, it's basically this integral, right? I mean, this evaluated at t equals
1.
all right, what is the cosine of pi? Minus 1. Well, the minus is 1, 1 and 1 is 2. So then you can say this is good here for t greater than 0, pardon me, greater than 0, less than 1. And y of t will be equal to 1 over pi times 2 for t greater than 2. I mean greater than 1, pardon me, greater than 1. Or equal, yeah, greater than 1. Do you all agree with that, class? Show of hands here, how many see this? How many worked that problem? Took a look at it. All right, I mean, be honest with me about this. Work these things. They are extremely challenging. So the next set you get are going to be more challenging than the press. That was a fairly easy set of homework. They're going to be more challenging, and they get much more challenging very quickly. All right, because convolution is something that you have to have your head on straight. You have to understand every facet of this at the rate we go through all this stuff. All these problems you should get down and understand every facet of it before we get into the next set. Because if you don't, if you have some uncertainty, by the time you get to the next set, you're going to be just, where do I start? I don't know what I'm doing. I'm being honest with you too. I'm trying to give you a fair warning on this stuff. It's really hard. Yeah.
How'd you get the two on that last question?
What's cosine of pi? All right, you'll notice that now when we evaluate this, think about this. We do this integral, right? We take integral of sine pi lambda d lambda. Well, that's what you get, this, right? But we evaluate t between 0 and 1. Well, when t equals 1, it's 1 minus cosine of pi. Cosine of pi is minus 1. So I have 1 minus a minus 1, or 1 plus 1, or 2 over pi. Okay? All right? Good. Hey, did y'all get the link I shared on OneNote? Everybody? All right. I want to make sure that. And the video link, did y'all get? All right. You didn't get it? You didn't get it? It's on OneNote. I literally stuck it there. So I was going to email it, and then he made a suggestion of just put it on OneNote. It was a smart thing. Now, you can't lose that, right? Well, maybe you can.
If you lose access to your OneNote, then we will.
Well, you just need that link, right? You can get it from any of your classmates. It's not something where it's not looking up your MAC address or something to confirm that you have access. It's a simple sharing link. That's all it is. Now, I wanted you to, today, I was going to get into some of the discrete convolution, but I'm going to stick with continuous time. I want to do one where we have two empirically defined functions and do the convolution form, but there's a trick. There's going to be an offset in this one. So I want you to pay close attention to this one. This is where the next set of problems are coming from. What I'm going to do is say we have two functions. The first function is going to be this. And this is going to be, I'll call it h of t. That's the first function. The second function is going to be this. And this is t. All right? Now I've got two functions. You'll notice it doesn't start at 0, the first function. You notice that. The second one does. But now I'm going to do convolution. First, which function has the most going on, the biggest change? Class?
What's the second one?
Second function, it's the exponential one. I'll call this x of t. So that's the one you don't flip and shift. Everybody got that? That's the one you leave alone. So I put it up here. And I go ahead and I put my x of lambda here, and that just looks like this, right? It looks like e to the minus a lambda, and visually you can see it starts at 0, and this is lambda. Does everybody agree with that, class? Now the next one, we flip and shift it. When we flip it, the only thing that happens is we take this whole thing and spin it, right? Right? So it looks like it's going in the minus direction instead of positive, right? Just flip the axis. So it looks like this when I flip that one. This is going to be plus 1. And now this is my h of minus lambda. Correct, class? Everybody see that? Now that right there shows you the value of h of minus lambda as if t added to that was 0. Understand? Everybody see that? Now I know when I put t in here, first I'm going to make sure everybody sees this. This is a very important point. Y'all got this? Now, what I'm going to do is this. I'm going to add the t to it. But I'm going to move it. Don't start erase or doing anything yet. Listen. Now I know if t, I don't need to add positive t. I'm going to say if t is minus 1, it would move the curtain right to this point. Wouldn't it, class? How many see that? So now I'm going to make the stipulation that that's 1 right there. So this point, think about it now. If that's 1, right, well, I'm trying to say this in a way that's going to make sense to you. This is going to be t plus 1. Think about it. When t is minus 1, it's right at 0, isn't it, class? Y'all with me on that? If t is minus 2, it shifts it down to minus 2. Follow me on this, class? T is minus 2, it shifts it down to minus 1. Right, class? With me? So now, when I look at this, t plus 1, I want to say for this, yeah, I can do it that way. I'm going to run out of time talking about this. Now, can you all see that really what happens when I do this? I'm going to start my integration at a point where it's going to go not from 0, oh boy, I'm done with this class, but really what I should say is this. When I move this thing, this is what it would be when t is equal to minus 1, right? Are you with me? Now listen carefully. Yes, sir?
To alleviate some of these problems, would it be easier just to right shift both functions by 1?
No, you can't shift both. You can only shift 1. And I was going to mathematically make a statement about this, but listen to me. Right there is t equals minus 1. Do you agree with me there, everybody? Now look, as this curtain starts drawing here, that's minus 1, and it starts drawing, what you're doing is you're going to start pulling it over and you're going to integrate this thing, right? But your limits are going to be from what? It's going to be from
0.
Well, it'll start at 0, but it'll go to t plus 1, right? T plus 1. I'll do this next time. I'm sorry, I'm out of time here. I'm going to tell you there's some trickery here. I'll make it clear to you. Really, the thing is, your integration is going to start at 0, but it's going to end up at t plus 1. Understand that, class? T plus 1, not minus 1. Got it? Yeah, it's tough. It gets even more tough. By Friday, we'll be going. It's unreal.
Yeah, no, it makes flipping, and let's make starting base.